Okay, we're back with another case solve, this time Mortal Wombat. This is the last knockout case that I haven't uploaded a solution to, so after this video I'll be happy to be through those, and then there's only 2 more in the Las Vegas finals which I haven't done. So full disclosure, I'd never be able to complete this case in the time limit just because there's a lot to read and try and get your head around in terms of rules here. But actually when you get into the case it's not that complicated. So let's briefly explain it. You're basically going to have wombatants. This is like Mortal Kombat but with wombats. They have a move list which are of varying lengths, and you go against a training dummy up until the last level where you go against a real opponent. And those moves are listed here with letters. They each have a base damage amount unless they are blocked. So a punch is blocked by a block or a duck. So if the opponent does D, or B at the same time that I do a punch, then that punch does no damage, otherwise it does 1 damage. And the case is going to ask us to calculate damage numbers. Now for most of the questions, I'm going to text split this on the comma, which will leave only the letters, and then I want to look it up into here. So these are combos where, those 3 letters pop up in a row, you do a special combo and get that damage. So let's just clean this up a little bit, because they're all essentially the same thing. So let's delete that out. I don't need the command names anywhere for the special moves, and then I have a nice table of stuff. So let's just delete the commas out, and we're going to call this move. We're going to call this damage, and then I'm going to create a symbol for what it's blocked by. So let's text split this on comma space. That's going to give us that. Then let's take the left of those, so left, and then concatenate them back together. So concat, and then that's going to be what the moves are blocked by. I'm just going to delete out all these NAs because they don't matter. And let's call this blocked by. I'm going to try and do these bonuses at the same time I do the questions. They all rely on question numbers, so question 2, 3, 5, 6 and 7. So the first question is just to add up the base damage of all these moves. So this should be fairly straightforward. We're going to text split that on the comma, like I said. That's going to give us a list of letters. We then want to XLOOKUP those letters in moves and give me the damage numbers, and we would like to sum it all up. So that's question 1. Now question 2, we're going to be going against a training dummy, and we need to negate each damage number where it's blocked by the opponent's move. So I'm actually going to set up a model now, because a model is going to come into the case for pretty much all the rest of the levels. So I might as well start it now, and then we can build on it as we go. So first of all, I want to text split this on a comma, and then I want the opponent's moves as well, so let's just do it this way, and let's get a move number. So let's do sequence of count A of this. I'm going to do it all in array formulas because the length of the moves are going to change later on. So this is my moves, opponent's moves, opponents. And then let's get out the base damage. Let's call it damage. That's going to be XLOOKUP this in move, give me the damage. And then I want to know what it's blocked by. So again, that's just XLOOKUP this in the move and give me what it's blocked by. Spelled move wrong there. So we know that a punch is blocked by B or D. The opponent does do a B, so this move is going to be blocked basically. So we basically want to check if the opponent's move is in here, then it's blocked. So let's say blocked, and let's search for this in this, and that's going to give us a number where it is blocked because this letter exists in this string. So then let's say is number. That's going to give us a true or false to determine whether it's blocked or not. And then final damage is going to be if this, so true or false. So if that's true, give me 0 because it's blocked, otherwise give me the damage. And I actually need to remember to keep these as array formulas the whole time, so that when I change my data table number, this automatically expands or shrinks. So equals sum of this, that's going to be our damage, so that matches the example. But there's also a bonus question here, which is how much of total damage is blocked. So we want to do the sum of the total damage minus the damage that was done at the end, and that will give us how much was blocked. Hang on, something's wrong. I want the sum of that. There we go. And then let's just data table all of that, and we should be good to go. This case takes a fairly long time, so hopefully I can get this out within half an hour. No one likes a really long video. So that's that, and the sum of the total damage blocked is here, which is 150. So let's put that in, 150. Okay, question 3 is introducing universal combos. So now we can do these things here. So let's start to build that into our solution. So we no longer have an opponent, and we just want to pull out the universal combos. So I am going to keep this as my base stuff at the moment. So let's just do, so here's all my base damage, and I'm going to do a different color for special combos. Let's just get rid of this data table for now. I'll add that later on when I actually start calculating damage. For now, all we want to know is where they occur. So I basically want a list of all of these in 2s. So I have a lambda for that, which is going to be equals split text of a string. So I want to concat this back together. What that does is it spits out letters individually. The reason I'm using the split text lambda is because I have optional arguments here to group things into 2s. So that's going to group things into 2s. But I want overlap here, so I want PP, PK, and so on. So let's give it that optional argument to split into groups. So now I have everything. The problem is this should be down here, and I want it all in arrays to work with the calculations here, and I want the array to be the same size as my other arrays. So I will vstack it with a 0. I need to put a bracket at the end because it's a lambda, it doesn't like it. And now I have all of my 2-letter strings. So I need to get all the 2-letter strings and 3-letter strings out and then match these to check if they're a valid combo. So let's now do the same thing, but let's do groups of 3 instead of groups of 2. I also need to stack one more 0 on it, so that it starts here, so PPK, PPK. So the question was asking to sum up the turn numbers where a universal combo happens, and the bonus question is asking how many of each universal combo were performed over the whole of the level and what's the minimum number. So quite a lot to digest there. This is where I was talking about the case taking a long while because of the instructions, and it'll probably take me a little while to explain them as well. So basically I want to do X match this in here, because this is the universal combos. And what should happen is you can see that this is a combo DK and these are combos. So I want to know if this is a number. And one thing to note, which will also come in handy later to keep things neat, is that these can never occur at the same time. The reason for that is if for them to occur at the same time, the 2-letter moves would have to be contained within 3-letter moves. So DK would have to be the end of these, or JP would have to be the end of those, and it's not. So they can never finish at the same time, in which case these are always going to be offset. So I can put this into one formula, and this is true of the damage numbers and the block as well. One block is never going to impact one of these things but not the other because they don't occur at the same time, so it doesn't matter. So that'll be useful for later, but for now let's just add an is number on here. And let's do the same here. And then I basically want to do an OR on here, because if one of them is true, it will give me a true. So this is basically my column of where the universal combos happened. So let's do sum ifs, the turn numbers, where this is true. And what I'm actually going to do is I'm going to extend these down a bit because I don't have an array formula on here. That's way too far, but that's fine. And then I will need to extend this down as well because these won't cover the array. So basically we have 95, which matches the example. And the bonus is asking how many times each of these occurred. So for that, the way I'm going to do it is I'm just going to spit these out across the top here, transposed. And I want to count how many times this happened. So let's do concatenate all the moves. And I have a count occurrences lambda. So count occurrences of this, and let's lock it to row 4 of this text, and let's lock that. So that's going to tell me how many times that happened, how many times this string is contained in this string. And underneath that lambda, all I'm doing is substituting this string with this, and then comparing the lengths and dividing it by the length of this. So that should give me the bonus and the question. Okay, so let's get this set up for the bonus. So we want to sum all of those because that's how many times each universal combo occurred. The minimum is 9, so let's put our answers in and put 9 for the bonus. Okay, question 4 is asking us to calculate the damage for basic moves and universal combos. So we basically want the first question again. I'm also going to set something up for later. So for later on, we're going to add in these moves that are special combos unique to certain characters. None of them can be blocked, but to keep the model neat, I'm going to copy this again, but change it to a 5. And I'm going to have to stack 2 more zeros with it, so that should be good, and then let's make that an array. So this should be ppktk, which is these 5, and then we carry on down. And now I want to basically do this calculation again. So let's put our special moves in a different color here so we can distinguish between them. That will do. So the damage, we're going to look up this in the moves and give me the damage. Let's put a 0 if it's not found. And then we want to plus on the same for the 3 moves. Remember, they cannot overlap, so it's fine to do that. If they could overlap, you would need to keep these split into different columns. So that should give me all the damage. And then blocked by is going to be this. And if it's not blocked by anything, we'll put that. And we want to then concatenate that with what the 3 moves are blocked by. So we can put an ampersand and that again, and we can move this across. And again, we'll only ever get one letter because they don't overlap, we can do that. So then if it's blocked, if when we search for, so we need to change this to example 4. So this is going to be blocked if we search for the opponent's move in there, then it's blocked. So any true here. So nothing is blocked. Okay, I think that is right. So now let's do our final damage. So our final damage is if this, so if it's blocked, then do 0, otherwise give me the damage. So that's for our normal move. Plus if it's blocked here, give me 0, otherwise give me the special damage. So that should be our total damage. And the answer is 29, and that matches the example. So let's then say equals sum of this. And this isn't an array, so I just need to correct that. And then we can get rid of this, and we should be good because the array sizes will change. And I don't think there's a bonus attached to this level, so we're fine there as well. Okay, example 5. A match is finished whenever a Wombat deals 100 or more damage to their opponent. So let's put in example 5. The problem is, this doesn't sum to 100. So they're actually going to recycle their move list, and it can carry over so that these combos can, you know, the next one should be PB. So what I want to do is stack this list on top of each other as many times as needed to be able to total 100 damage. There's a number of ways you could do this. You could just use the repeat function on these two things, or I have an alternative, which is a vstacks formula, which I can just say vstack that 20 times over. I think that's enough because it does tell you in the question. So there's a hint here. It will not need more than 250 moves. So I think the minimum length, so let's do length over 2 to get rid of the commas just to be safe. So the minimum number of moves is 16, and 16 times 20 is 320, so yeah, stacking 20 times gives us enough. So let's stack the opponents as well. And I think that's basically all we need to do, and then change our formula. So this time we want to say xlookup 100 damage in, oh, we need a total damage column. So let's actually use scan 0 this sum to get a running total. And like I said up here, we want to xlookup 100 in the running total, give me the move number, exact match or next large item, and we have 144, which matches the example. There's also a bonus here, let me remind myself what it is. How many times do they restart their cycle of moves? Okay, so we want to know how many moves they have. So let's do length of, substitute the comma out of this. For nothing. So they have 23 moves. So we want to divide the total number of moves by how many moves are in their list. So this is how many moves they took 144 moves with 23 or whatever it was in their list. That is 6.26. So they recycle their moves 6 times. So we basically want to round this up to get how many move lists they did, and then we want to minus 1 off it to get how many times they recycled. So let's redo our data table here. It might help if I just put in the right question numbers for level 5. So let's do that. So our total recycled number is 83, and these are our answers. So let's put those in, and then 83 on the moves recycled. The original way I tried to actually do this, which is wrong, is to do my division as so. Let's just put example 5 in. And then round down. So I know that 6 moves have been used. But that does not get you to the right answer, that gets you to 85. And the reason is because these two you use an exact number of times. So you use exactly 5 moves, so you don't recycle 5 times, you actually recycle 4 times. So this is why you need to round it up and minus 1 instead of just taking the integer portion, because those two will trick you out and you will get the entire bonus wrong. Okay, next up, level 6. Now we have all of this set up. This is pretty easy. Do I have any more bonuses? What bonuses do I have? I have a level 6 one. So because I've already set this up, this is fairly straightforward. So all I need to do now is figure out what this person's special move is. So I'll look for the person in here and give me their special move. And this can't be blocked, so on my damage calculation, I'm going to say plus if this string, and I can do it as an array still, equals this, give me whatever the damage is for that, so I can just look it up in here. Otherwise, give me 0. So you're going to see here we have a bigger score because we have that special move happening there. And then let's put in our question numbers for question 6. These should be the answers. We also have a bonus here, so let's do that while we're on the question, which is how many times was the final move a universal combo or special combo? So we know what the final move was. Let's just get rid of our data table here. So the final move was 53. So let's say index, the special damage for the move where the game finished. And basically if that's a number, then we've done a special combo. But we need to also add if, let's do it index again, but this time that, so index that on this number. So if that is the special move, then give me a 1, otherwise give me a 0. So now when I data table it, we want any time that this is a positive number. So let's say equals that, greater than 0, and let's put it in a minus minus. So that happens 11 times. And then the final question, again, should be straightforward because we're completely set up for it now. So 2 Wombats go against each other rather than the training dummy. And we want to know what move a winner is declared. So we need to basically calculate this both ways round with these 2 columns flipped. So let's do example 7. I'm just going to get rid of this data table. We also want to pull this out to J. And let's just put find our special move for the other player here. And let's copy this fully out for the other player. And this time I want to make the first column be player 2 and the second column be player 1. And I need to change the special move to be this special move. I need to move over twice by the looks of things. And then let's just put a black box here so we can actually distinguish between the 2 characters. Hopefully that we can make that a bit smaller as well. So what do we want to do? We want to figure out, there's a bonus here as well, so we might as well do it at the same time. The bonus is basically saying that multiple Wombatants tied for the most wins, and the ultimate champion is the one that took the least damage during their wins. So that's a bit of a mouthful, but let's do it all. So first of all, let's say XLOOKUP 100 in, actually first of all let's put the players up here. So let's say equals this for player 1 equals this for player 2, and then let's do player 1's score. Actually, let's do it like this. So player 1's score, so equals XLOOKUP 100 in here. That's actually, I think these arrays are now different sizes between the characters sometimes. So I'll sort it out at the end. So XLOOKUP 100 there, give me the move number, exact match or next larger item. So Joey Cage would have won on move 58, and let's do the same for Ray Dundee. So we want that and that. Whereas Ray Dundee, how you say this, ends on move 49. So the minimum number is obviously the winner because they took 100 damage off earlier. We also, for the bonus, want to know how much damage the winner had taken. So first of all, let's figure out our answers. So the answer is actually the minimum of this and this. And then the winner, I'm going to say if this is this number, then the winner's player 1, otherwise the winner's player 2. So that's our winner. And then we want to know how much damage the winner had taken. So again, I'm going to say if this is player 1, then we want to know how much damage Johnny Cage had taken. So we're going to do index damage that Johnny Cage had taken on by move 49, because that's when the game ends. Otherwise, we're going to index the damage that the other person had taken on move 49. So that this number is always going to be less than 100, because obviously if they've won, they've done 100 damage to the other person and they're still alive, so they have not taken 100 damage yet. And these are the three things we want, basically. So we want move number that the game ends, the winner, how much damage the winner had taken. Let's now put in our data table. I think we'll get some errors here because the ranges, if I put in 112, the X lookup ranges are not the same length here. So what we're going to do is we're going to change this to be N5 to N500, and change this to A5 to A500. That fixes that. It looks like it fixed it all. So let's put in our answers. I think this is the minimum, the turn. So this is when the game ended. And then for the ultimate winner, we basically want to do a group by on this. So we want to group by the names, and the values are the damage that they've taken. And the function, we actually want two functions, and you can H-stack them in here, which is a trick. H-stack doesn't auto-populate, but you can actually use it. So if you H-stack two functions, so rows, sum, then what you would get is basically a pivot table, a group by, but with the two functions. So that is a very nice little trick that you can do. So these are the wins. So it's basically saying rows of this for these people. So these are the winners. So how many rows are there here? So when there's 4, it means these people have are the winners. They're all tied for 4 draws. And I want to know who took the least damage out of those. So I sum the damage they've taken, and it's 248. So 248 is our answer. You could also do this with an old school pivot table, just for instructional purposes. So I could basically say, oh god, that's annoying. I could basically put the names in the rows, the count of the names, and the values there. Obviously these headings aren't quite right. They should be called name and damage taken, but that doesn't matter. And again, you'd have to then manually, okay, those are all 4, so they have 4 wins. Which is the lowest number? 248. Group by seems to be the best way to go about it. And that is it. So hopefully we're under half an hour. Not sure. I'll see when I edit the video. But there's a fairly efficient and streamlined solution to this case.